Hello everyone. So today I'm going to solve this question number 47. So in this question we have to match some spectroscopic things are given to us in group 1 and we have to match them with their respective frequency. So first one is electron spin resonance. So electron spin resonance is basically when you have an atom, or if it has a lone pair of electrons. So when this particular material is you have an atom, it has a lone pair of electrons or unpaired electron. When it is subjected to the magnetic field, so these electronic energy levels will split. And now suppose you are providing a radiation, so this splitting of energy level, they will absorb this radiation. So by that spectroscopy you can determine the structure. So this is a very helpful technique while uh, examine and studying in deeper level. Okay. So the for electron spin resonance, the frequency that we generally use is microwave. So what generally happens, suppose you have an atom and if it has unpaired electron, and this unpaired electron allows us to interact with magnetic field, and this magnetic field, you know that this magnetic field will split this electronic energy levels, and this electronic energy level when radiated with this microwave frequency will absorb the radiation, which is equals to difference in energy level, that splitted energy level. So for ES is electron spin resonance, we use micro frequency, and you know that spin electron is associated with a spin. So that is why it is called electron spin resonance. And nuclear magnetic resonance is just similar to electron spin resonance, but in this case, you know that nucleus is consist of neutron and proton. So for NMR, the spin of nucleus should not be equal to 0. Means nucleus should have a spin. For NMR to happen, the spin of a nucleus should have some term. It should not be 0. Okay, so the same way when you are like subjecting this nucleus to a magnetic field and irradiating it with some radiation, so what will happen, this nuclear level will split in the presence of magnetic field. And the same way for nuclear magnetic resonance, we use radio frequency. So we know that for P we are getting microwave frequency, and for Q, nuclear magnetic resonance, it is radio frequency. So we know the answer is D, but still we will solve these other two option that is given to us, R and S. So electronic transition is possible when the material is absorbing EM radiation having UV or visible component. So it is possible. So electronic transition, visible component. S is 2, so we are left with R is equals to 4. The transition between vibrational state of molecule. We know IR radiation, IR spectroscopy, in which change in the dipole moment is required when during vibrational of a molecule. So for using infrared or far infrared range radiation, we can observe transition between vibrational state of a molecule. So for ESR we use microwave frequency. For NMR we generally use radio frequency. For to study transition between a vibrational state of molecule, we use infrared range, and for electronic transition it is visible range. So the answer is D. Thank you.